Okay, welcome, students. Let's go over section 1.1 and 1.2 today. So 1.1 and 1.1 is on key terms in sampling. So we're going to identify the populations, samples, parameters of interest, and statistics. We're going to classify a piece of data as categorical or quantitative. We're going to calculate and understand percentages, including pie charts. Okay, what is statistics? Statistics is the study of data, okay, how we get various pieces of data and variation and how that data varies, okay, and we want to quantify that somehow. Okay, data is the collection of observations and or measurements along with its content, along with its context. Okay, population, okay, think of a population as all the data we are interested in considering. So the population, this contains all of the possible data in that category. Okay, so as opposed to a sample, that's a sub-collection or only some of the members from the population. So the population is the whole. Okay, so if we were to think of a population, say maybe the population of the NBA players, okay, that's the population, that's the entire thing. Whereas a sample, okay, a sample would just be, say, maybe the Los Angeles Lakers. Okay, so the Los Angeles Lakers, that's a sample of the entire population. It's a subset, okay, or a sub-collection. Okay, so population is the entire NBA. Lakers is the sample. Okay, a parameter, okay, is a single number or some characteristic of the population. Okay, so think P with P, okay, population parameter, and then sample S and statistic. So sometimes we call the parameter for average, okay, the mean, and the parameter is a Greek letter called mu. Okay, that means the average of the population. Okay, whereas the statistic, okay, is a sample statistic, or the average, we call that X bar. Okay, so this is the average for the population, and this is the average for the sample. Okay, so we have different names if we're talking about a population or we're talking about a sample. Okay, a few common measurements that you may have heard of are mean, standard deviation, mean or average. Okay, so average parameter or average statistic, standard deviation, proportion, median. Okay, let's do a sample population. Population, the heights of every adult in the US, that's a population, the average height of every adult in the US. Okay, why is it a population? Because it's every adult in the US, it's everyone. Okay, the parameter is the average height. Okay, that again would be that mu, sorry, that mu. Okay, that's the average of a population. Okay, and this is a Greek letter called mu. Okay. Okay. Maybe it's more like this, mu. Okay, mu, like Mewtwo, like the Pokemon. Okay, or just Mew, the Pokemon that came before Mewtwo. Okay, he's a clone. Mewtwo is a clone of Mew, just in case you want to know. Okay, so mu is the average for a population. Okay, sample would be 500 randomly selected adults from the United States. Well, how do we know that's a sample? Because there are a lot more than 500 adults in the United States. Okay, so this is a sample. Okay, 500 sample, and sometimes we call this 500 the sample size. Sample size. And we refer to that as lowercase n. You should rewrite that, lowercase n, there we go. Okay, the sample size n, that's the 500 there. So n would equal 500. Okay, the average height of 500 people, this is the average height of the sample, therefore that's a statistic, and we would say that's x bar. Okay, again, this is called x bar. Okay, so if you, that's how we name that, okay, the average. Okay, let's look at some populations and some samples here. Okay, we want to know what the proportion, percentage of California will be voting for Mr. Lewis in the next election. We call 50 random numbers in California and ask, are you planning on voting for Mr. Lewis in the next election? What's the population? The population would be all the voters in the next election, right? Okay, so this would be all voters in the next election. What would be the sample? Well, the sample is the 50 random numbers that we call. Okay, 50 random numbers that we call. What's the parameter? The parameter of interest. Are you planning on voting for Mr. Lewis? So we want to know the proportion up here. Okay, the proportion or percentage. So the parameter of interest would be the percentage of California voters voting for Mr. Lewis. Okay, in the next election. What's the statistic? The statistic would be the percentage of the 50 random people that we called. So this is the percentage of the 50 random people called who are voting for Mr. Lewis. Okay, the percentage of 50 random people called who are voting for Mr. Lewis. Okay, medical testing. We use a machine to measure the amount of cholesterol, LDL, from a blood test. We want to find the average LDL of patients using certain medication. We test 4 blood samples from 4 different people currently using the medication. So what's the population of interest? Well, the population would be all those we test 4 blood samples currently using all those who are currently using the medication. Okay, which we can't sample, probably can't sample all of those who are currently using the medication, but we can sample a few of them, or in this case, 4 of them. Okay, what's the sample? The sample is the 4 people selected. Okay, 4 people selected. That's the sample. Okay, 4 people selected currently using medication. Okay, currently using the medication. Let me make that a little nicer. Be able to see that a little bit better. Okay, 4 people selected currently using the medication. What's the parameter of interest? We want to know what? We want to find the average LDL. Okay, so parameter of interest would be the average LDL, okay, of Okay, all people using the medication. Okay, and what's the statistic? The statistic is the average LDL of those 4 people selected. Okay. Okay, so out of a population, we select a sample. Population, sample. Okay. Because oftentimes it's rather difficult to get the entire population. Sometimes it's even impossible. Okay, sometimes you can do it if you have, you know, access to the entire population. However, if you were to do something basically like, you know, try to survey all adults in the United States, well, good luck. There are people dying every second. And so you're not going to be able to get the entire population. At very least, you'd be able to get a very large sample of the population. So, and again, it's often cost prohibitive to try to sample, you know, a ton of people when if you can sample maybe 1,000 or 10,000 people, it suffices. It's pretty good at that point. Okay, sampling frame. A good sample must have a random component, and our sample can only be representative of a group from which we sampled. We call the group the sampling frame. We hope the sampling frame is the same or at least representative of our population. Okay, so we want to get a good sample, a good random sample. Example, a statistics student is interested in studying the study habits of math students at Santa Ana College. Out of all the math classes during the spring 2017 semester, the student randomly selected 25 sections, and then within these 25 sections, he randomly selected 10 students. After analyzing the result, what is the group of students that the study can be used to represent? Okay, well, we can use our sample to make conclusions about about the Santa Ana math classes in the spring semester, spring 2017 semester. So we can use that sample to conduct some sort of understanding of the study habits of math students. Okay, but we're gonna take a sample of that and not survey everybody. Okay, categorical versus quantitative, or what I like to say, qualitative versus quantitative. Okay, qualitative meaning that there's a quality, okay, and quantitative meaning that there's a number, quantity. Quality versus quantity, okay? Think category or quality, data that consists of the names or labels. The only way to measure data consists of names and labels. The only way to measure categorical is by counting the values that fall into a given category, okay? For example, eye color, title, position, weather, okay, sunny, rainy, these are all categories. They're all characteristics, okay? As opposed to quantitative, okay, think quantity. Data that is measured in numbers always has the same sort of units. Height, salary, temperature, all, okay, are quantities, okay? So they're come in physical numbers, okay? Height, physical number. Salary, number. Temperature, number, okay? They're it's numerical data. Okay, it's not blue, it's 5. Okay. Okay, examples. The ages in years of survey respondents. Is this quantitative or is it categorical? Is it categorical or quantitative? The ages in years. Well, an age is a number. It's a quantity. So this is going to be quantitative. Okay, political party. Is political party a number? No, it's a label. So political party, that's categorical. Okay, Social Security numbers of survey respondents. Now think of this. Is the Social Security number a category or is it a quantity? And you might think, well, it's a number, therefore it's a quantity. It's actually not, it's a category. Okay, why is it not a quantity? I'll put quantitative and then I'm going to cross it out. Okay, it's not quantitative. The reason is because I can't add, subtract, multiply, and divide. Okay, even though it's a number, I can't add, subtract, multiply, and divide Social Security numbers and get another Social Security number. Okay, they don't work like that. It's the same as with zip codes or area codes, right? So if you add 805 and you add 626, right? Those are area codes, 805, 626. Are you going to get another area code? No, you're going to get 1400 and something, right? So 31. Okay, if you add them together, you don't get another area code. It doesn't work. Okay, so it's the same thing with Social Security numbers. You can't add, subtract, multiply, and divide. So you always ask yourself, can I add, subtract, multiply, and divide these numbers? And if you can't, okay, if you can't or the result doesn't make any sense, then it's categorical. Okay, so this one is categorical. Okay, understanding percentages. 525 people take a survey. 65% of the respondents claim they find statistics useful. How many people claim they find statistics useful? Find the exact calculated value of the percentage. So I want 65% of 525. Okay, so I remember back to middle school math class. This is going to be 0.65. Of means times, and that's 525. Okay, so let's go to the calculator on this one. So I'm going to go 0.65 times 525, and I'm going to get 341.25. Okay, so this is the exact. Okay, this is the exact number, except I can't have 0.25 of a person, right? Because this is 525 people take a survey, 65% of the respondents claimed that they find statistics useful. Okay, so how many people do you think actually responded that they find statistics useful? Probably 341 people. Okay, I don't want to have a quarter of a person because that's not a full person and things get messy if we talk about quarter people. Okay, let's try this one. 120 people stated statistics is boring. What percentage believes statistics is boring out of the total 525 people? So I'm going to say, well, 120 out of 525. Okay, again, let's do that on the calculator. So 120 divided by 525, that's going to be equal to approximately 0.02285, 0.02285. Sorry, not 0 point. Okay, 22.85. So I'm gonna change this and round to the third decimal place here. So that 5 is going to tell me to bump up that 8 to a 9. And so this becomes 0.0229. And now I'm going to change this to a percentage. Well, how do I change a decimal to a percentage? I have to multiply that by 100. Okay, and that moves the decimal over twice. And so I get 22.9%, okay, of these people who were surveyed think statistics is boring. Okay, in a Harris poll of 2,302 adults, 14% said they have a tattoo. What is the exact value? That is 14% of 2302. Okay, so the exact value. So again, 14% of 2302, okay, that's going to be 0.14 because that's 14% as a decimal, times 2302. Again, let's bring up our calculator. Bring up the calculator. Let's clear this. And I'm going to go 0.14 times 2302. And I get 322.28. Okay, so that's the exact value. Could the result from part A be the actual number of adults who said they cannot, they have a tattoo? No, because we can't have 0.28%, 0.28 of a person. Okay. No, since you cannot have 0.28 of a person, at least legally. Okay, and therefore, let's rewrite that. Therefore, this was probably 322 people. Okay. Okay, what was one possible number? Oh, this is C. We have C here. That who actually said that they have a tattoo? It's 322. Right, 322 people. Boom. Okay, among the 2,302 respondents, 46 said they had face piercings only. What percentage of respondents had face piercings? So we just want a percentage here. 46 out of 2,302. Okay, so again, let's go to the calculator. 46 divided by 2,302 is 0.01998. So 0.01998. Ooh. Okay. So what does this round to? Well, this 8 is going to round this 9 up to a 10, which is going to bring this over, and that's going to make that 9 a 10, and then that's going to bring over the 1. And so this all gets rounded to 0.02. Okay, because it keeps bumping things up as we keep rounding. Okay, so 0.02, okay, or the way that you could think about this is that we get the 2 because this is 200, right? So it's if you think of 1998, what's that going to round up to? Well, that 1998 rounds it up to 2000. So we get this 0.02,000. Okay, and then what's that as a percentage? Well, we multiply this by 100. Okay, which means we move the decimal over twice and we get 2. Okay, 2.000%, or we could just write it as 2%. Okay, Vince divided his month's expenditures into 4 categories: rent, food, fun, and other. The amounts she spent in each category are pictured here. Using the graph, approximate the percent of total spending devoted to food. Okay, so we want the percentage, right? So the first thing we need to do is figure out, well, a percentage is something out of a whole. And I need to know, well, how much money is there total? So let's find the total expenses. So that's going to be 244 plus 306 plus 412 plus 138. Okay, so let's calculate that. So 244 plus 306 plus 412 plus 138 is equal to $1,100. So that's $1,100 total. And we want to know, okay, approximately what percent of total is for food? Well, food was the 244 here. So I can take 244 out of 1,100. I'm going to divide that, multiply by 100. Okay, so divide 244 divided by 1100. That gives me a decimal. Let's multiply that by 100 to get my percentage. And this is 22.2. Okay, I can round that 0.18 or 18 to 20, so 0.2%. So about 22.2% was dedicated for food. Okay, types of studies and sampling methods. Okay, any good method of selecting a sample usually requires a random component. Number 2, identify good sampling methods. So we want a simple random sample. That means that the data was selected randomly. Okay, so some other things that we're going to cover here is a stratified sample. What's a stratified sample? What is a cluster sample? And what is systematic sampling? Okay, what is stratified, what's cluster, and what's systematic? Okay, the other thing that we want to do is know the difference between observational studies and experiments and what they can tell us. Okay, types of studies. The first is an observational study. Okay, observational study is basically what it is. We just observe, gather data, and then make a conclusion. Okay, an experiment is not just an observing. An experiment is you have a couple of things. You have a control group and you have an experimental group. Let me make that a group. And you have an experimental group. Usually the control group, in the control group, there's something called a placebo, okay, that you give so that, they think that they're getting something, but they're actually not, okay. And then we gather the data, and then we see if there was any difference between the control group and the experimental group. Okay, observational studies observe and measure specific characteristics. Experiments impose a treatment and observe the effects, cause and effect. Okay. Okay, let's see what we have here. Is this an observational study or an experiment? Okay, let's see what we got. Okay, in a study sponsored by Coca-Cola, 12,500 people were asked what contributes most to their happiness. 77% of the respondents said that it was their family or partner. Okay, so is there a control group? No, this is just people being asked a question. Therefore, this is an observational study. Okay, in a clinical trial, the cholesterol drug Lipitor, 188 subjects were given 20 milligram doses of drug, and 3% of them experienced nausea. Okay, so this is a clinical trial. It's a controlled experiment. So this is an experiment, okay, and it had a treatment, and the treatment was Lipitor. Okay, so the treatment was, a 20 milligram dose of Lipitor. 20 milligrams. Okay, dose of Lipitor. And they don't specifically tell us if there was a control group with a placebo, but I'm gonna say that, they did their due diligence and that there would be a control group with a placebo here. Okay, so this is definitely an experiment. Okay, C, I'm interested in seeing if running at least 1 mile daily can lead to reduced weight. I find the average weight of 25 people who claim to run daily and the average weight of 25 people who do not run daily. Okay, so we have people who do and people who do not. Okay. Those who claim to run daily have an average weight that is 15 pounds less than those who don't run daily. Okay, so can I make the conclusion that running can reduce your weight? Well, is this a controlled experiment or is this observational study? Well, I didn't specifically control the experiment because all I did was ask 25 people who run daily, claim to run daily, okay, and the average weight of people, 25 people who do not run daily. So all this is a survey. This is just an observational study. Oops, sorry about that. Okay, this is an observational study. Okay, because I'm not controlling the experiment. I'm not saying, okay, you 25 people, you go run on the treadmill, and you 25 people, you don't run on the treadmill. And then over a period of time, when I gather the data, I'm not doing that. All I'm doing is just going up to people and saying, oh, here's 25 people, here's 25. All I'm doing is observing at that point in time. Therefore, can I make the conclusion that running can reduce your weight? No. Okay, and this is something called correlation, where something may be correlated, but it's not caused. Okay, no, this is not a controlled experiment. Okay, therefore, correlation, I think there's 2 R's in correlation. Correlation does not imply causation, okay? As opposed to the controlled experiment where we could give someone a pill and see if that pill directly impacted, some sort of outcome. This is just me going randomly to people who may or may not be running, okay? How can I change the study so it allows us to see if running causes reduced weight? Okay, well, we could select people at random, okay, people at random. Okay, maybe, and we'll do 50 because it was 25 and 25. Okay, have 25 run and 25 not run over a given period of time. And calculate their weight. Okay, so we could be in charge of the experiment, okay, that way. Okay, in observational studies, if we're just going to observe, we need to make sure the samples we do observe is representative of the entire population. In order to do this, we need good sampling methods. A good method requires some sort of randomization process, okay? randomization. Okay, 5 sampling methods. Okay, 1, simple random sample. Okay, or what we call SRS. Okay, stratified sampling. Okay, so we'll talk about what that is in a second. Okay, cluster sampling as well. Systematic sampling. Systematic sampling is when you just use a system. Use a system to sample, like every 4th person. Okay, you're trying to do randomness, and then that's used. And convenience sampling. Convenience sampling is sampling out of convenience, and that's not very good. Okay, that it would be like saying, hey, you know what? I would really want to see if people like dogs, and then convenience sampling would be you going to Petco and asking people if they like dogs. Okay, that's convenience sampling. You're not really going out of your way to get the most accurate data. Okay, so if you're in Petco and you like dogs, yeah, you're probably going to get, you know, some skewed statistics there. A random sample. Members of the population are selected in a way, and each individual member in the population has an equal chance of being selected. Okay. Simple SRS, simple random sampling. A sample of n subjects is selected in such a way that every possible sample of the same size n has the same chance of being chosen. Okay, example, I want a simple random sample of size n equals 5. Okay, so simple random sample. So you somehow randomly select 5 people. Okay, like pulling 5, this would be like pulling 5 names from a hat. Okay, doing some sort of lottery system. Okay, so make sure that there's some randomness. Okay, a convenient sample. Okay, results that are easy to get and not random. Okay, like we talked about, going to Petco and asking if people like dogs. Okay, or going to the library and asking people if they like books. Okay, this is just convenient sampling. Okay. Okay, systematic sampling. Okay, select some random starting point and then select the every kth element in the population. So this is systematic. So like every 3rd, right? So this would be every 3rd can of Coke. Okay, every 3rd can of Coke. Okay, let's look at what is stratified and what is clustered. Okay, stratified and clustered. Okay, in stratified, we subdivide the population into at least 2 different subgroups that share the same characteristics. Then we draw a sample from each subgroup. Okay, so if we take, say, classrooms 1 through 5, and then classrooms 6 through 10, okay. Okay, and then we select from each subgroup. Maybe we select 5 here, and okay, from this subgroup, and 8 from that subgroup. We're selecting the same number. Okay, select the same number from each subgroup. Okay, so that's stratified. Cluster, okay, is we divide the population into sections or clusters, then randomly select some of those clusters. Okay, so we could say that, we could, say that we divide this into 10 different clusters, and then we select randomly, we select 2 of those clusters. Say we select 8 and 10 here. Okay. And so it's a cluster. It's less random. Okay. Because you're just saying, oh, okay, out of these classrooms of people, I'm just going to select 2 of them. Okay, and those 2 are going to be representative of the whole. 2 clusters are representative of the whole. Okay, think of it as like clusters of grapes, right? You're picking these clusters of grapes, okay, off of the grapevine. Okay, and you only pick two clusters of grapes, okay, off of the grapevine. And you're saying, well, those 2 are representative of the entire vine. Would they be? I don't know, maybe not, okay? But if you're subdividing things and then you're taking the same number from each subdivision, that stratified is a little better, okay? Stratified is a little better than cluster sampling. Okay, cluster versus stratified. In stratified, groups are called strata. Sample some elements from all strata, right? It'd be like if I went down these, I planted the grapes in certain rows, right? So we planted a bunch of grapes here, a bunch of grapes here, a bunch of grapes here in each row. And then what do I want to do? Well, I want to sample a vine, or sorry, a cluster of grapes from each row. Okay, I don't want to just get 2 clusters that represent the entire vineyard. I would want to sample, say, 10 rows, each row. Okay, I'd want to say, oh, these grapes are doing okay over here. These grapes are doing okay over here. And you'd say, okay, pick 1 from each row. Okay, you're going to get a much more, okay, homogeneous data, because if one is varying, you would be able to say, oh yeah, that one's varying, and you say, okay, well, this row of grapes didn't do so well, but the other 6, 7, 8, 9, 10 other rows did. Okay, strata tend to be homogeneous. Okay, have an attribute that is all the same. Each strata alone does not represent the population well. So just one strata doesn't represent the population. Okay, clusters. Groups are called clusters. Sample all elements from some cluster. Okay, so so this whole thing was a cluster. You sample, each of them from a cluster. Okay, clusters are usually assumed to be heterogeneous, all mixed up. Okay, each cluster alone is a good representation of the population. So, so it's a different way of doing these. Okay, so what are some variables that exist on a plane map above that may influence a passenger satisfaction level in terms of their experience on the flight? Okay, well, obviously what section they're in. Okay, maybe closeness to the bathroom. I don't know. Okay, how much, what section they're in. That's obviously maybe legroom. That would have to do with what section you're in. The food, the staff. Okay, how much attention the staff member is giving to each section. Okay, describe how you might perform a symptom random sample in this survey. Okay, take a random sample. Of 50 passengers. Okay, using a lottery system, like the last number of their plane ticket. Okay, last number of the plane ticket. Okay. Describe how you might perform a cluster sample to give the survey. Which variable listed in number 1 might you use as your clusters? Okay. So out of the 50 people, okay, I would cluster them. Okay. You know, so what you might do is you have 5 sections. Okay, 5 sections in the plane. Okay. So out of the 5 sections, you're going to have 10 people in each section. So 10, 10, 10, 10, and 10. And what clustering is means that you pick, okay, well, this is stratified. Let's not do that. With clustering, what you do is you say, well, I'm only going to choose 2 of the sections. Here's 5 sections, right? So out of the 5 sections of the plane, we might pick 5, well, we want 50 passengers. So let's pick 25 passengers from one section, 25 passengers from another section. We have sections 1, 2, 3, 4, and 5. And so we're sampling 25 people from 2 sections, and we're saying, well, is this going to give us an overall understanding of the total population in that plane? And not necessarily, right? Because the people in first class are going to have probably a much different experience than the people in economy. Maybe the people in business class, you know, have a completely different experience as well. So, you know, this is, so out of 5 sections of the plane, select 25 people from 2 sections. So that's how you do the clustering, okay? Which it's not too good. Describe how you might perform stratified. Now that was what I was doing before. Okay, so to do stratified, we would say, okay, in a stratified one, we would want an equal number of people in each of them, 10, 10, 10, 10, and 10. So select 10 from each section. And what would I want to survey with them? Maybe food, you know, how was the food? How did the food compare in economy to first class, right? But we're getting an overall idea of the experience by having a stratified survey. Okay, cluster is going to just give us a bunch of people in 2 groups, whereas stratified is going to give us the same number of people over all groups. Okay, so if I was conducting a survey, I would probably do that using stratified. Okay, that's it for 1.1 and 1.2. I look forward to seeing you in the next video.